Okay, hello, everybody. Welcome back to our lesson 3.2 of a quadratic function, where we're going to be diving in deep into how to complete the square in using to find the maximum minimum value, which really means like a vertex, um, you know, of a quadratic function. So I did say if you watched the last video, I would talk about a bit more about the theory about completing the square, and it all relies on going from this form into something that looks like x minus h squared plus k, right? This is the form we want to get into. This is our vertex form. So why do we complete the square? Why do we follow the procedure that we did? And you'll kind of see the key here lies in our expansion of this x minus h squared, because what is x minus h squared? It's x squared minus 2xh plus h squared plus k. So if we go one step back and we kind of expand this out, x minus h times x minus h, we'll see that this is what we get. And this form is key to keep in mind, because we're looking for something like this now inside the bracket, so that we know that if we get something of this form, we can easily go to the form over here. So how do we get that? Well, I'll show it to you using an example. So we take the first example. The first thing I want to do is kind of group my x squared minus 8x terms and leave the plus 7 outside, because this 7 is part of my k and I want it outside the bracket. The only thing I want inside the bracket is my x squared, the first two terms ideally. And also important here is I want an x squared coefficient of 1, which I do have over here, so I don't have to factor anything out. Here, the first step would be factoring out a 2 from my first two terms, so that I, again, have something that looks like, again, the a could be 1, or if there has to be an a value, it should be outside the bracket. Now, let's look at our form here. Again, x minus h, this could be a plus h, depending on whether h is positive or negative. But let's look at what's inside our bracket. I have an x squared, I have a minus 2xh, and I have an h squared. So the key here is, look at what do we want to find? We want to find our h, we want to find our k, right? And so let's look at the similarities between this and this. So I have an x squared, that's a check. And this minus 8x, this part, looks suspiciously like minus 2xh. So what I'm actually doing is saying minus 2xh equals to negative 8x. That's what my second part is. And I can kind of can't simplify this. I'm going to remove the x, or divide x on both sides. And I'm going to divide both sides by negative 2, and I'm going to get h equals 4. And this is the reason why, when completing the square, the technique used is like, oh, we take this negative 8, we divide by 2. Why are we dividing by 2? Because there's a negative 2xh here in the formula, which corresponds to this second term. So that's why we divide by 2. And now that I have my h value, what am I missing? I'm missing an h squared, right? So I proceed to add my h squared in. And now this entire thing looks like what I want in the bracket. So this now can be simplified into a perfect square, exactly like I want it to be. But you know that I just pulled the 16 apparently from nowhere, so I can't just do that. So I have to take away the 16 as well. But what I'm going to do is that taking away 16, I'm going to group it with whatever I had on the outside. So minus 16 plus 7, I'm going to combine that with my k value, so that this here becomes x minus 4 squared. Again, I already knew it's going to be x minus 4, because I found my h equals 4, and this here is going to become minus, I can't add, 9. So my vertex here is 4, comma, negative 9. Again, we said that it opens up, so it's a minimum, and so this is the minimum value. Minimum value, I should say, is technically equal to negative 9. That should be my final answer, because that's what I was asked to find. Determine the minimum value, which was negative 9. So hopefully we see why we divide by 2 and why we take that squared. It's all because we want an x minus h squared in the bracket. And if I really expand that bracket, what I want is x squared minus 2xh plus h squared. So I do whatever I can to get whatever is inside that bracket into this form. Likewise, I factored out a 2 first because there was a 2 in front of the x squared that was bothering me. So now again, this has to look like x squared plus, in this case, 2xh plus h squared. So again, I take a close look here, and I see that my 2xh corresponds to this 6x. So if I try and solve for my h value, you'll hopefully see that my h value is 3, because 2xh equals 6x. Divide both sides by 2x, and I get h equals 3. And now I want a plus h squared, so I'm going to add plus h squared inside this bracket, so that now this looks like my x minus this form essentially is what I want. But again, this plus 9 has to be canceled out because I can't just add things that I want to randomly. I will take this negative 9 outside the bracket, but there is a negative 2 or a positive 2 out here, so I have to be careful to make that negative 18, because when I take it outside, I do have to multiply it by the 2. And now this becomes x plus 3 squared. I already knew that because my x value was 3 here. And my minus 18 was negative 7. So my vertex here is negative 3 comma negative 7. And I know, so I did maybe confuse a couple of people, because here I had h equals 4 and I had minus 4 here. It depends on what form you take. If you stick with the negative 2x, I would actually, it'd be probably easier if you stick with the positive 2xh and make the positive, so that well, actually, you shouldn't be doing that. You should actually stick with the negative. Okay, the idea here is that, sorry to confuse you. The idea here is essentially it all depends on what this sign here is. If this is a positive, you will get an x plus 3 squared, but your h value, which is this, is actually a negative 3, right? So this is actually a negative 3. If you have a minus 8x, whoops, here we go again. Sorry about that. Again, if you have a minus here, that means you're in your equation, you'll get an x minus the h value, which means your h value is actually positive. So again, the signs might be a bit confusing. Please don't get confused by what we're doing here. And again, this was just an explanation for the process of completing the square, which is, again, you take this value, divide by 2, take the square, add and subtract, take the subtracted one outside, complete factor this essentially, which you will get a perfect square for, add whatever's, left over, and that's what you do to complete the square. So hopefully this didn't at least make it more complicated. Hopefully it simplified things. But again, the key here is do lots of practice, homework, practice all the time, and you will get the hang of completing the square. Again, if you want to do the straightforward method, I'll just do the first one again, or the second one. So the first step here is so we have 2x squared plus, what was it, 12x plus 11. Again, this is just for those of you who really just want to know how to complete the square. First step is you factor out anything in front of the x squared from only the first two terms. Again, group the first two terms, factor out anything from the x squared. That's step number 1. Step number 2, find your h, or your magic number, as they say. You're going to take whatever number you have here, which is plus 6. You're going to divide it by 2, and you're going to take the square of that. This 9 is our so-called magic number, which is actually just h squared, and we are going to add that number and subtract that number inside the bracket. That's step 3. Step 4 is taking this subtracted part outside the bracket, but don't forget to combine it with anything that's in front of the bracket. So this becomes minus 18 when it goes out. And step number 5 is just factor this part, which we know will give us a perfect square if you just factor that normally. And then this bit, again, two numbers that multiply to 9, add to 6 are 3 and 3. So that kind of idea. And here we have a minus 7, and this is our completing the square. This is a step-by-step format, and you always just follow the same rules. If you keep doing this over and over again, you will get the answer. So hopefully that confused us less and made it clear what we have to do, even though it doesn't really tell you why you're doing it. Okay, now we're thankfully back to the good stuff, the easy stuff, partial factoring. Well, remember, group the first two terms. And again, I did a lot of partial factoring in our previous video. That's why I said I'm going to go over this. But I'll explain it again for those of you who haven't watched the previous video. For those of you who have, you can essentially skip this. These are easy questions. But the idea here is you group the first two terms and factor out an x from there, so that this is the partial factored form. And from the partial factored form, what we get are actually two symmetrical points, which are, you kind of take the factors of these two brackets here, like we just find, just like we found the restrictions. You're just going to say x equals 0, x equals 2, and my y value here is going to be negative 8. Because if I say x equals to 0, put it into my expression here, you'll see that this thing is going to be 0, so I'm going to get y equals negative 8. Same goes for 2. And because they have the same y value, these are symmetrical points. And that turns out to be very handy, because with symmetrical points, I can easily find my axis of symmetry is by just taking the average of the x coordinates of my symmetrical points, because I know symmetrical points are equal distance away from my axis of symmetry. And then to find my vertex, I'm just going to put my x coordinate into my equation. You can put it into this part or this part, it doesn't really matter. Y equals 1 times 1 minus 2 minus 8. This is negative 1, so negative 1 minus 8 is negative 9. So my vertex is 1 comma negative 9. Again, the x coordinate of the vertex is the same thing as axis of symmetry. So here I found my minimum value of negative 9. Again, how did I get that it was a minimum value? A value is 1, or positive 1, importantly, so it opens up, so it has a minimum value. Again, hopefully we're okay with that bit. Again, first a value is negative 4, so it opens down. So I have a maximum value. Let's establish that first. Let's factor out, let's group the first two terms and factor out whatever I can. X plus 3 plus 5. Again, note the difference here. When partial factoring, I do factor out the x, but when I do completing the square and I'm factoring stuff out, I don't factor out the x. I just factor out the number, the a value in front. I still have an x squared here. So that's an important difference between partial factoring and completing the square. Please don't get confused there. So we have here again our two symmetrical points. 0, comma 5 and negative 3, comma 5. Symmetrical points. My axis of symmetry therefore becomes the average of those 2 points. I'm going to say 3 over 2. At least we're in grade 11. We're going to start doing stuff in fractions more than decimals. Decimals are sometimes imprecise, and we don't like imprecision, so we like to use fractions. But I mean, 1.5 is pretty precise, so if you wanted to use negative 1.5, it's not the end of the world. We're going to sub that into our equation here. Negative 4 times negative 3 over 2 times negative 3 over 2 plus 3 plus 5. And this actually happens to be, what is this? Whoops, I can't cancel this because I have to add first. So negative 3 over 2 plus 3 is actually positive 3 over 2. Now I can cancel. So I'm just left with what appears to be positive 18 plus 5, for 23. So I have my vertex. I don't really have to state my vertex, but just in case. So my maximum value is equal to 23. All right, so hopefully we'll see that that's what we're doing. I'm just going to do you guys a favor, I guess. And let's check the homework and see what homework we are given. 145. Is that 145? Yeah, 145. Question 2, 3, 4, 5, 7, 8. Okay. Oops. Okay, let's take a look at this. 2 is easy. State whether it opens up or down. Just look at the A value. 3, state the zeros. You should be able to do that. Take the roots of these guys. Direction of opening, A value is negative. You should be able to find that. Equation of axis of symmetry. Again, you have your symmetrical points because you found the zeros. The zeros have the same Y value. 2, 0, and negative 6, 0, right? So these are our zeros. And so axis is, these are symmetrical points because they have the same Y value. And axis of symmetry means you can take the average of these guys and average of the X parts and find the axis of symmetry. So we're okay with that. Parabola on the right, state the vertex. You just read that off of here. Equation of axis of symmetry, domain and range. This should be easy peasy. I think we did 5, 7, and 8 is what we had to do, if I'm not wrong. So graph each function. So again, hopefully we're okay with this. We've done a lot of direction of opening, vertex, axis of symmetry. Again, you can do this, check your answers. I'm just going over it just to see if there's any difficult questions or questions that I will point out here. Parabola on the left, this should be easy stuff. Easy stuff. Now, again, the idea here is that some of you will feel very accomplished in doing all the homework, which you should be. But again, always remember to scroll down and make sure you can do questions like this, or, even questions like this or this. And this is really where we're getting our questions from the assignment for. I know it's not part of the assigned homework, but it says extension here, and that's like an application question. So ideally, you would be trying these kinds of questions. And so we shall, in fact, take a look at this question. So the company's profit on sales of computers is modeled by the function this. So that's a quadratic function, where X is in thousands of computers sold. So, okay, this is the profit. The company's profit on sales of stereo systems is this guy over here. So calculate the maximum profit the business can earn. So we want to calculate the maximum profit the business can earn. So let's take it. So this is the company's profit on computers. This is the company's profit on stereo. And we want to maximize both the profits. So we have to find a way to somehow combine these two equations and then maximize that equation. So how are we going to do that? I really don't see a simpler way to do it, unfortunately, because we just have to combine the profit we made with computers, plus the profit we made on stereo. And then we have to add those two equations. So here we have negative 2x minus 3 squared plus 50 plus negative x minus 2 times x minus 7. And well, this is certainly an interesting case. Hold on a second. Sorry. I just realized something, that this is actually not the right way to do this question, because that is too painful and long. So I thought there had to be something wrong with that. And that's always a good check if it's like too complicated. You're doing something wrong. The idea here is that we don't have to actually add the two profits, because the maximum profit that the business can earn is actually just the maximum profit they get from computers plus the maximum profit they get from stereo. If people intuitively thought that, that's good on you. That's the easiest way to do it. So here we see that the maximum profit, this is already in vertex form, so the maximum profit that we get there is 50 K or 50,000, because the profit is in thousands of dollars. And then for that, so that's the profit on computers. Profit on stereo systems, again, we have this factored form over here. So we have our two symmetrical points. Our axis of symmetry is actually 2 plus 7 divided by 2, or 9 over 2. And so our actual maximum value is, if you put 9 over 2 into this expression, which actually gives us, I believe this is 4.5 minus 2 is 2.5. 2.5 times 2.5 is 6.25 plus 6.25K. So this maximum profit just turns out to be $56.25K, or, $56,250 is the maximum profit this company can earn, because the maximum profit is just the maximum profit of the computers plus the maximum profit of the stereo system. All right, now let's look at question number 16 to see if we can do that. Again, this was a complicated word problem. It even confused me for a second. But the actual math that we did here was not very, it's just the same thing that we were doing all along. It's just in context, you might start to confuse yourself as I did. And the idea is we're not going to do that. And how do we not confuse ourselves on a test? Is we try this question before going into a test. And that's the easiest way to do that. So difficult golf shot as well as 100 meters from the hole. So let's see, let's draw some diagram here. We start at some point 0. Here's the hole. He wants the ball to land 5 meters in front of the hole. So he wants to land at 95 meters. A 20-meter tree is between his ball, 40 meters from the hole, and 60 meters from Jim's ball. So 60 meters away at 60, there is a tree over here that is 20 meters tall. With the base of the tree as origin, so here this completely ruins the system I've been drawing so far, so I am going to change that. This is now 0, so I will change this to negative 60. I will change this to 35. And I will change that to 40. So as you can see here, I didn't completely despair. I easily adapted my system just so that to change it so that it was as the question was asking. With the base of tree as origin, write an algebraic expression to model the height of the ball if it just clears the top of the tree. So the ball went somewhat like that and fell down at 35. That's a very bad parabola, but there you have it. The key thing I want to point out here is the easiest mistake to make during this question is to assume that 0 or this point 0, 20 is the vertex, which we are not given. It just says cleared the tree, but we don't know where the actual maximum height of the ball is. We do know that when it crossed 60 meters, it was 20 meters high, but we don't know, it could have gone to 25 meters high before falling down. So we actually don't know where that maximum height is, so it's important to not assume the vertex. But what we do know here are the roots, because we know where it's touching the ground. It has to touch the ground where it started, obviously, and it also has to touch the ground where the intercept is. So we can write the height of the ball equals some value a, which we don't know. We always have to put that value in there. X plus 60 times x minus 35. Maybe I should not be writing here and confuse you. Height equals a, x plus 60 times x minus 35. This is a start to the algebraic expression. And we know that for an x value of 0, my height was 20. So I can easily sub that point in to calculate my a value. So a equals 20 divided by 60 times negative 35. 3a equals 1 over negative 105, negative 1 over 105. So my final answer, height equals negative 1 over 105 x plus 60 times x minus 35 is the algebraic expression for this golf ball. And there we go. That's the way I did that. Okay, we'll look at some of these thinking questions before we, actually there is more homework to do. Well, it's okay. You don't really have to follow along the video. I'm just doing this for people who do have questions with the homework. Okay, quadratic function, x equals -1 is the equation of axis symmetry. X equals 3 is the x-intercept. 32 is the maximum value. Determine the y-intercept of this parabola. Okay, so we have a couple of pieces of information here. We'll begin to construct our parabola. We know our maximum value, and we know our equation of axis of symmetry. So right away I can write something that looks like x minus, or x plus 1 squared plus 32 a over here. I do know that my a value is negative because I have a maximum value, so it has to be downward facing, but I don't know what exactly the value is. But I do have an x-intercept here. So what that means is when x equals to 3, y equals to 0. So I can say 0 equals a times 3 plus 1 squared plus 32. 0 equals a times 16 plus 32. 16a equals -32. A equals -2. So hopefully we'll see the algebra I did to get to a equals 2. And as soon as I have that function, to find the y-intercept is fairly easy work because I do have, well, let's look at the -2 x plus 1 squared plus 32. This is a complete equation of my parabola. And to find the y-intercept, I know that's where the x value is 0, so I just put in an x value of 0 here. Y equals -2, 0 plus 1 squared. This is just plus 32. So y equals 30 is my y-intercept. So my 0, 30 is the y-intercept. So that's how I found that. Again, just putting together pieces of information. Let's see. Hopefully we know how to graph this. How long will the rocket be in the air? So let's look at this 4t squared plus 32t. Again, there's no intercept, so I can easily factor out a 4t to get this. So I have my symmetrical points, which are 0, 0, and 8, 0. So my graph is going to look something like at 8, like that. So I know the rocket will be in the air for 8 seconds because it started at 0 and then it landed back on the ground after 8 seconds. How high will the rocket be after 3 seconds? You sub in x equals 3 into your function. What is the maximum height? To find the vertex, or the y component of the vertex, again, I find my axis of symmetry is the average of the x parts of my symmetrical points, and then I put that back into my function to solve for my maximum value. And voila, I have my maximum height. So there we go. That was part of the homework. I have question 153. Let's take a look at what's on there. Question 1 to 4. I see. Again, maximum value, easy stuff. Maximum, this is just looking at the parabola. Find the maximum and minimum value. We've done plenty of practice with this. This is more practice. I would recommend trying some of these questions. Again, determine maximum, minimum value, 2 different methods. So we've learned to complete the square. We've learned partial factoring. And just looking at the further questions. So this is an interesting question, and we'll get to these kinds of questions. I'll put a halt on the questions for now because we're going to talk about word problems later on. So we'll get back to some of these questions, as I'm sure they'll be part of the other homework. The homework for this unit seems to be fairly straightforward. 170. Let me just check that. Question 5, again, determine maximum and minimum value. The homework for this, I know there's a couple of questions. The this section that there were word problems, but we do have a lesson fully on word problems, so we'll probably get to that in more detail again when we actually have to do those questions. So until then, stay safe, and I'll talk to you soon. Peace out.